Generic stack is the same as generic list, but operates on a LIFO principle. That is, last in, first out. Like in a company, the last people hired are the first people fired. Or in a stack of cards, the last cards you put on the top of the deck are the first cards that you take off the top of the deck, and hence the name stack. A good use of the generic stack is to keep track of actions that the user has performed in your application, so that, for instance, you can roll these actions back or display all of the actions. In this lesson, I'll show you how to use generic stack. So let's say we want to track user actions as they work in an application, so that we can list the history of actions the user has taken, as well as enable the user to perform a redo or an undo. We would go about it something like this. First, we would create a class called user action, public class user action with the following properties. Tab, for instance, a description of what the user did. Tab, and an abbreviation, let's say. And let's say an object ID, the ID of the object that they acted on. We'll create some here so you can see more how this will work. So first we'll create a generic stack of type user action, and we'll call it user actions. And it's going to be an instantiated object like that. And then we'll add some user actions. So let's say user action equals new user action. And the description is, let's say he created a report. And the abbreviation for this is CREAP. And the object ID, the report that he created, let's say is 34. So we have our first user action. And now we need to put it in the collection user actions, which is a stack, a generic stack. And instead of add, we say user actions push. So you push on the stack the user action in question. So for the example, let's just create 3 of these. So I'll have to make the scope local like this. And then we'll make another one and make that scope local too, so that we can use the same variable. I do this in demos a lot. It's probably not the best programming practice, but allows you to copy code like that. So let's say that the second user action is added graph to report, and the abbreviation for that is add graph or something, and he added it to object 34 as well. And let's say he then deleted report, and that has an abbreviation of del rep, and he deleted the same one. So these are the 3 things that he did. So what can we do with this? Well, just like in a generic list, we can list them out. And in this example, that would be, for instance, user action history. And we use the for each in the same way as in a generic list. So we have user actions here. And we'll display simply let's put a little bullet there, user action. And what do we want to display? Let's do a method to display it. And Visual Studio will give us this nice little option to create a method stub, which it did. And then we can do a right click and go to definition. And there's our method stub. And we can then display the contents of the object, for instance, return string format, and this will be the description, this will be the abbreviation, and it is affecting the object and the ID for the object. And then we have to put in our variables, description, abbreviation, and object ID. Object ID, I'm doing control space here to get that IntelliSense rolling there. And now we have show it, which is fine. And we show it here, which is fine. And now we should get some output. So if I run it, it says, user action history. He deleted the report, affecting object 34. He added graph to the report, affecting object 34. And created the report affecting object 34. Let's change this to, let's say 11, just to make sure that something's not being repeated. Yes, so all of this seems to work just fine. Now, we can show, for instance, the last action. Last action was, for instance, and then, for instance, we have to say user actions and then peek at the last one, and then show it. So we get that the last action was the deleting of the report, which is correct. We first created the report, then we added graph to the report, and then we deleted the report. And here we see if we peek in the collection, we get the last item that was added or pushed onto the stack. So now let's emulate an undo by the user. Let's say the user clicks a button to undo one of the actions that he has done. And so what we need to do is take the last item that was pushed onto the stack and pop it off. And that's exactly what you say. So we can say user actions, or let's actually get the object and display it. So we can say here, user action undone user action equals user actions and then pop. So it pops it off of the stack and puts it into this variable. And now we can show the undone user action. Show it and say this action was undone. And let's run it. And we see that the last action was deleted report. And then this action was undone, deleted report. So now in the collection, in the stack, deleted report is no longer there. We only have these two. So let's make sure that that is indeed the case. And what we need to do there is just, we don't need this line here. I'm doing Control L to copy this so that we see the user action history again. And you see here that the last action was deleted report. Then this action was undone, deleted report. So the new user action history is simply create and added. And we see that the deleted report action has been undone. So you saw here a concrete example of when generic stack would be a slightly better choice than generic list. Use generic stack anytime you want to keep track of a collection of objects, which should go onto a stack and then be taken back off one at a time. For example, when you simulate user actions and want to give an undo feature to your users, or for instance, when you want to emulate the back button, for instance, in a browser. All of these are instances in which you would want the last in, first out functionality of generic stack.